Thank you. I'm going to talk about the Ruby 2.0, what we want to accomplish in the near future. And I'm Matt, as I'm introduced. And this is my tweet, and Yukihiromasu. And if you read Japanese, please follow me. If you don't, I don't know. Okay. We have released the Ruby 1.9.2 last month, 2 months ago, about a month ago. Then we just started the Ruby 2.0 works. Then we just started discussing on it. So before introducing about explaining about the Ruby 2.0 features, I'd like to talk a little bit about history. The first released version of the Ruby is Ruby 0.95. So when the project was very started, I started with the 0.01, and I increased the version numbers daily, so about mostly daily. So I released it in the December 21st, 1995. And as a tradition, the Ruby releases tend to be in the holiday season, like December 21st. So a year later, I released the Ruby 1.0 as a Christmas present. You know, the Japanese time is 18 hours faster than the United States. So I released the Ruby 1.0 in Japanese time. So the Ruby 1.0 is sleeping in the socks while you are in the bed. So Ruby 1.2 was released in 1998, the Christmas Day. And Ruby 1.4 is August. And maybe you don't know that, but in the middle of August, we Japanese have some kind of the small holiday season. It's called Obon, which is rooted from some kind of the Buddhism tradition. I don't know. I'm a Christian, though, but I enjoy holidays anyway. And so I released Ruby 1.4 in the summer holidays in Japan. And for 1.6, I wanted to release it in the middle of the summer, but some bugs and troubles bit me, so I failed to release in the middle of the summer. So it was released on September 19th. And Ruby 1.8 was released on the 2003, the August 4th. And it's a little bit earlier than planned, but you know that the Ruby 1.8 was 7 years old. The half of the history of Ruby is spent in the 1.8 era. And Ruby 1.9 was released about 1.5 years ago, and the Ruby world is gradually shifting into 1.9. And we also have the alternative implementations like JRuby, Rubanius, Iron Ruby, and Maglev. You don't know Maglev, but Maglev is the Ruby. Ruby interpreter runs on top of the Smalltalk VM and the VisualWorks Smalltalk VM. So it's quite fast as a very optimized Smalltalk VM. And Iron Ruby is the Ruby on .NET, which is developed by the Microsoft itself. And the Rubanius is developed by a guy in the engineered, and it's written in C++, and the most of the classes and the methods are written in Ruby itself. Quite meta-circular-ish, the interpreter. It's quite experimental, but it runs faster than 1.9, but a little bit slower than 1.9. And JRuby is Ruby on JVM, and many of you guys might use the JRuby. Okay, and Ruby 1.9 was a big step. We introduced the YAV, the virtual machine, and the multilingualization. The YAV stands for the Yet Another Ruby VM. It started as the side project, a third-party project, and there were so many the Ruby virtual machine projects in the past, but it's quite easy to implement the very primitive VM, but the practical implementation of the virtual machine is quite difficult. The first there was the huge gap between the first step to the practical implementation, and out of many implementations of the Ruby VM, this one, the YAV, was crossed the bridge. So a few years back, I allowed to merge replace the core part of the interpreter. So the 1.9 has now new implementation of the virtual machine, and it runs on the bytecode, and it's quite fast. For very small micro benchmark, it runs 50 times faster than 1.8. And for most of the use, in practical use, the 1.9 is 2 times faster in average. So 1.9 is quite fast, and it even has rooms to improve performance in the future. Like we don't use just-in-time compiler yet, or we have some optimization left out. And multilingualization is the ability to handle the multiple language, multiple encoding, multiple character set in a single programs. Like many other languages like Java or Python use Unicode as a central code set. Unicode is very huge character set, so if you have any other encoding like the Latin one or the Japanese encoding or Chinese encoding, the Vietnamese encoding, so you translate into the Unicode, then process inside of the software, then translate back into the original encoding. So that's the Java way, or Python way, or any other language way. But maybe you know that we Japanese have lot of encodings, and we have been suffered encoding hell for last 30 or 40 years. Like we have at least 3 encodings to describe the Japanese text. Like we have ShiftJS and then EUCJP, or the JIS or ISO 2022 JP or something like that. So we have at least 3 encoding, and the Unicode comes in. We now have 4 encodings to describe the Japanese text, and you may not know that the encoding, the conversion is kind of like very messy. It's not the mathematics. It's kind of history, and it's so many corners and edges. So the problem is that we have at least 4 teeny variation of the SafeJS. So if you don't know the exact variation of the SafeJS of the original encoding, so if you translate the SafeJS text into Unicode, then translate back into the SafeJS, so you might lose the original information. The text will change, modified, in just the translate back and forth from the Unicode. So we got the yen sign problem. Historically, somehow the Japanese guy mistakenly assigned the yen sign, the Japanese currency sign, into the same code point to the backslash. So if you write the backslash n, we see the yen sign n. But that's okay. It's just the glyph problem. But some Japanese users use yen sign as a yen sign. So I want to write the 200 yen, so back in the translated into Unicode. And unfortunately, Unicode has both yen sign and backslash, which I have to translate into. If I choose to translate yen sign to backslash, so we don't have any problem in the backslash n, the new line sign. But if I translate back into shift-JS, we lose the information. Or if you translate the yen sign as a yen sign, you use the information of the backslash n. So the yen sign n in Unicode doesn't have any special meaning in the text. So the program will crash. So we have this is just only one example. We have a lot of things in the Japanese or Chinese or the Russian text or or Turkish text. Or the Turkish I has no dots. But so in Turkish, if you translate into the what at the capital I into the lowercase I, you have to remove the small dots on the I in Turkish text. Anyway, so we have a lot of problem in the encoding translation. So, and I suffered enough for a long time. So I just gave up translation, literally. So in Ruby 1.9, the original text, encoding the original text remains same without any conversion as far as possible. And if I translate Unicode text, I process it in Unicode. If you processing the shift-JS text, I process them in a shift-JS. So many people consider that approach is only the unrealistic or ideal text, but I prove it. It's possible. So it's a little bit complex, a little bit complicated, but if you don't try to process many encoding at one time, so it is very easier. Output text, then process. Don't forget to specify the original encoding. So just process them as a text. It's easier. And if you want to try handling the multiple encoding at the single program, yeah. If we want to do very complex things, the program would be very complex naturally, but you can help it. Anyway, so we introduced the multilingualization in Ruby 1.9, and these two, the new virtual machine and the multilingualization, is the very big step we made in 1.9. So the version number goes up to 2.0. But the changes are rather small, smaller than ones we made in 1.9. So the plans we want to make this is these, for example. So we try to introduce the keyword arguments in Ruby 2.0 and selector namespaces and traits and method combinations. I will explain these one by one. So sometimes the sequence of the arguments are confusing. Like one.step A.ia can be can read as a step by A to B or step to A by B. It's a little bit confusing, especially the ones you get used to the language like Objective-C or Smalltalk. So we like to make it possible to write like this, 1 step by 2 or 220. So no confusion. And if you're defining the method, you can specify like this. So you can resolve the ambiguity of the argument sequence. So select the namespace. So you do know that monkey patching. So in Ruby, you can modify the existing class and then replace the method or remove the method. So it's global modification, and it could have the huge impact on existing program, like this. If you replace the integer plus, 1 plus 2 makes 42. Whatever number you add the integers, you get the 42. 1 plus 2 makes 42. 3 plus 3 makes 42. And I'm sure this change will crash your program, right? But if you're working on a team, in a big team, you might have some stupid guy in your team. And somebody got this to crush your project. I don't want that. You don't want that. So we'd like to encapsulate the modification in certain namespace. This is not the fixed spec, but this is just the concept. So in the stupid namespace, you can modify the integer class to make it 42 by addition. But outside the namespace, so you safely add the 1 plus 2. So you can jail the stupid guy in the certain namespace. The traits. The Ruby has no multiple inheritance. Its multiple inheritance is very, very complex, can be very complex. And the mixins is the kind of multiple inheritance, but very disciplined way. But still problems remain. But when including the other modules, so the method name can conflict. But Ruby don't warn you about the conflict. It's just resolve the method calling sequence in the priority order of the included modules. So we don't have any conflict detection. We don't have any conflict resolution in the mixins in Ruby. So we are planning about the traits, which is the kind of the newer way to address these problems. Okay, this is the current Ruby module. We have two modules, foo and bar, and defining a new class, including the foo and bar. So we have the priority order, then the C, then bar, then foo, and the object. So the Ruby will look for the method in this order. But if we have the method of the same name in both foo and bar, and for different operation, so it has a name conflict. But Ruby just seek the method in that order, so the bar has a priority. So even if we want to call the foo the method in module foo, so we have no way to skip the bar, right? So we are going to introduce the new method named the mix, which warns you about the name conflict. So we mixing, not including, mixing two modules, and if foo and bar has the method of the same name, so it just fails. And if you replace the mnet by renaming it, the specific like this, so you can resolve the name conflict. Right. And the method combination. Have you ever tried the alias method chain in the active support? It's quite, renaming the original method to keep the original method, and then redefine the original method, then call back the alias method. It's quite, primitive. I don't like that. I don't want to wrap the method afterwards. So if you add the module into the existing class, it is go back. It is put in the lower order than the method defined in that class. But if you put module or the functions in front of the class, you can wrap the existing method. So we are going to introduce the prepend, not the include or mix, prepend module. So if you define the prepend, if you add a module using prepend, the method defined in the module comes in front of the original method. So if you create the object of the bar, then call foo, it would go this way, then before, then super calls this method, then go back to after, then returns. So the existing order should be before, foo, and after. You know what I mean? So you can wrap the existing method by modules. So this is called method combination, and it's the well-known feature in the Lisp community. The Lisp community calls this the method combination, and the Common Lisp object system has a bunch of complicated the way of method combination. But the Ruby is much simpler than Lisp in many ways. So I just want to provide a way to wrap the existing methods by prepending it. So, and at the same time, we are trying to improve the implementation. So we will have the faster, smaller, and soft real-time and embeddable interpreter we are trying to make. So no one complains about the faster Ruby, right? So some complaints about the Ruby is slow or something like that. But the Twitter was originally written in Ruby. If you can make up the website has a higher traffic than Twitter, and it's a great success of business. So you have money, so you're safe to hire the Java programmer to replace it. No problem. So, but no one complains about the faster Ruby, and many people decide implementation language by alias shootout. Silly. It's kind of like a micro benchmark, like calculating Fibonacci or solving n-body problem, or the calculating Mandelbrot set or something like that. And it doesn't do anything about the web programming or something like that. So it's kind of silly, but people decide language by micro benchmark. So we'd like to address these kind of micro benchmark for that purpose only. But we will try, since no one complains about faster Ruby. And then the current Ruby was developed on Linux, so that it's highly optimized on the Unix system. Sometimes it has a problem on the Windows system or even smaller system. But some people in the small device software development requires the productivity which can be realized by the language like Ruby. Just because the software on the small devices are getting more and more complex these days. So they are very tired of making very complex software on a very limited resource and a very limited hardware. But current Ruby interpreter does not address about these kinds of small devices. So we want to make a new implementation of the interpreter so that we can address these kind of the small devices. And we would like to allow the multiple VM in the process so that no global variables and we have the VM structure for each virtual machine, so that you can assign the independent virtual machine for each threads, so that the threads in the process can run without interfering. In embedding system, and we need soft real time, not hard real time, like every process can every interrupt can handle in the 10 microseconds or something like that. This is hard real time, but soft real time, like a gaming platform. Like it's you can wait for 100 milliseconds, but you don't want to see the 2 seconds pause in the shooting game for garbage collection. Shooting the enemy, it stops for garbage collection. Garbage collecting, then enemy goes away and your bullet goes like this. You don't want that. So it's kind of like the trade-off on the throughput and the latency. And the nowadays technology trends tend to lean to latency. So for example, that we have long running process, so that there's huge memories, so that the tracing the garbage collection has long time to trace and sweep the garbage. So for Ruby 2.0, we will continue to work on the YARV, the canonical Ruby 2.0, and we started the lightweight Ruby, which Professor Tanaka introduced you, and which we codenamed Write, light and write. Yeah, it's quite difficult for us to distinguish L now. Right. And it's totally new implementation. Write is the Ruby subset for smaller computers. It's embeddable and configurable. So, for example, we have the embedding system. It's the implementer is one-off. You can configure the smaller implementation. Yeah, we don't need we don't need I/O in the refrigerator or something like that. We don't have any file system on refrigerator, so you can remove the I/O totally from the Ruby interpreter, right? With Ruby interpreter running on the refrigerator, something like that. So we can the small computers like the games, digital appliances, factory automation, or some other application area. And in games industry, the higher level logic in better language, like the platform is written in C++, and the higher logic is written in like Lua. It's the language from Brazil, and for example, but as a language, Ruby is better. I believe. But the current Ruby interpreter is not good for embedding into the game or anything. But if you once we have the lightweight Ruby interpreter for embeddable systems, so we can replace the Lua to Ruby, the game programmer can be happier. I hope. And the digital appliances. Many appliances similar to PC, like a digital TV, has the CPU and the memories and the hard drive and some controllers. They are driven by software mainly. So we have a lot of lines of code in the digital appliances, like the digital TV, and the software developer for these appliances also requires productivity, so that in the somewhat near future, like 5 years later, so we will have the digital appliance on which software runs in Ruby or developing in Ruby, maybe this very graphical, some kind of it has browsers or some kind of, I don't know, a lot of features in reasonable price. And the clouds, in these recent data centers has getting bigger and bigger, and the power consumption is very huge. So the cloud machines tend to be less consuming power, replacing by the computers that consumes less power. For the biggest cost for the data center is the power. So the Google planning to replace the data center computers to Atom processor. So for the Atom consumes less power, and it has less performance, but it is good enough to run a web server, so it's okay for them to have more computers in less power. So in these kind of less powerful computers, this kind of the lightweight Ruby is very suitable, since it's supposed to consume less power as the software. And the distributed programming runs better by this kind of lightweight Ruby. It's called assigning the small virtual machines into the multiple cores, and then they communicate with the message passing, like actors. So it was small. The implementation with the small footprint and the latency priority is better suitable for this kind of environment. So this is the end of the slides. So Ruby 2.0 has a software feature, language feature, like I described, to maintain to address the scalability of software or development team and the system themselves. And for implementations, we will make Ruby better and faster. And at the same time, we'd like the new implementation, the lightweight Ruby or Write, which is suitable for small devices or maybe cloud systems. So by providing these kind of technologies, we'd like to help the world of the environment of the programmer better, and then make programmers feeling joy in their daily programming. Thank you.